Alright, welcome back, guys. First, I would like to give credit to the authors of this material. This material is from Jump Remix. Thank you, guys, for letting us use your material. Now, we will be tackling all theoretical questions on vector and equilibrium of forces. All theoretical questions will be tackled here. 1. Skip. 2. Skip. 3. Skip. 4. Skip. 5. Skip. 6. Skip. 7. Skip. 8. Skip. A lot of questions here are calculations. 9. Skip. So we're looking for questions where we do not need to calculate. 11. Skip. Not clear, but skip it. We'll skip these. And okay, we'll find a question. Question 14. So we're starting our theory from question 14, right? Let's get straight into it. Which of the diagrams in figure 5 gives the correct resultant R of two vectors P and Q? Let's see. IV, this one gives the correct one. 14 is option D. 15 skip. 16 skip. 17 skip. 18 skip. 19 skip. 20. Let's tackle this. Which of the following is in a natural equilibrium? A heavy weight suspended on a string, a cone resting on its slant edge, a heavy base table, the beam of a balance in use. 20. Let me scan through. They say which of the following is in a natural equilibrium position. I think it's supposed to be. Right, guys, let's jot down a few points. Unstable equilibrium equals cone, C-O-N-E, on its apex. Next, stable equilibrium equals cone, C-O-N-E, on its base. Lastly, neutral equilibrium equals cone on its slant edge. So question 20 is a cone resting on its slant edge, because they ask for neutral equilibrium. Here you see. Thank you. Skip. For the physics, we have a whole lot of calculations to cover in the next couple, in the shortest time possible. Skip. Alright. The figure above shows three different ways of hanging a heavy picture from a hook. The tension in the string would be greatest in dash. The tension would be greatest in this one. Where is the both of them are XX. Greatest is supposed to be greatest in Y. I think there's an error here. Well, we'll let it be. I will continue, because you're having the both of these things showing same and you're having Z here. So I would look for this question probably, because we are going to be treating a whole lot of different, we would use different materials to treat questions. So hopefully we'll come across this same question again. It will surely be repeated, then we'll tackle it proper. 29. The figure above shows a uniform circular object with a center R and diameter PS. PS is the diameter, center is R. Then diameter PS, then that's all. 29. A point between R, okay? A circular section, the center Q and a diameter PS is cut away from it. If PQRS is a straight line, where is the center of gravity in the figure? A point between R and S. A point between this R and S, you have center of gravity. 29 is option D. 30 skip. 31. Which of the following statements are correct about an object in equilibrium under parallel forces. In equilibrium under parallel forces, the total clockwise moment of the force about any point equals the total anti-clockwise moment about that same point, correct? The total forces in one direction equals the total forces in the opposite direction, correct? 31 is option A. Okay, 31 is option A. 32, this question actually the answer is 0, but I need to show you how to solve it. I won't just pick all the answers, so that's why we're tackling theory separately. A boy sits in a train moving with uniform speed on a straight track. If from its outstretched palm he gently toss a coin vertically upwards, the coin would fall dash. The coin will fall behind his palm. And this is because before the coin, if you toss the coin up, before the coin will return, the train has moved. Hence, the coin will fall slightly beyond his palm. You could try it in a car, especially like in a car or in a maybe flight. You could try it. Maybe a small coin. Just toss it. It will fall behind slightly behind your palm, not entirely down, just slightly behind. So it's not like you're tossing the coin too far. Just toss it up a bit. You see it will fall slightly behind. So option B, 35. 36, I'll need to show you guys how to derive this. It will be unfair to just say this is the answer. 38. In the figure, the weight X is held in position by pulling the rope KLM in the direction LF in this direction. Which of the following diagram shows now it's not clear again, but the diagram that would show it would be option B, this here. So you have like this, and another one coming down like this, which you add as your resultant. So you have force 1, force 2, and your resultant. Okay, skip. Alright, skip. All of the questions in these chapters, you have to solve them. Skip. Okay, the diagram above shows a solid figure with base PQ, see the base PQ, and center of gravity G on an inclined plane. Which of the following statement is correct? The solid will fall over if the vertical line cuts through. Okay, the solid will fall over if the vertical line through G, there's a vertical line like this, invisible one, up down straight line, through G lies outside the base. So 50 is option A. 51, a handbag contains some load. Calculation. Skip. There are about 80 plus questions here, and literally 90% of them are all based on calculations. Skip. Okay, the unit of moment of a couple can be expressed as, not clear, but I'm going to say the unit either ways. The unit of moment of a couple is per newtons, right? Per newtons. First, let's define moment. Moment is defined as the product of one. Moment is defined as the product of force and perpendicular distance. So Newton meter. Okay, 1 Newton, like one of the force and a distance. So Newton meter. It's not even here, but I think it's supposed to be option A. Because this one they say square. No, it's not supposed to be square. It's supposed to be option A, but it's not clear. 60, skip 60, 69. All the three forces must be concurrent. The upward force is equal to the downward force. The algebraic sum of the moment about any point must be 0. Which of the above conditions must hold for a body acted upon by a system of three coplanar force in equilibrium? Which of them must hold? Which of them must hold? Roman figure I, and I. 69 is option D. An aircraft attempt, skip. 71. Which of the diagram below shows the position at which a small ball bearing is in neutral equilibrium? A small ball bearing is in neutral equilibrium. Option D. This point is neutral equilibrium. 71, 72. Okay. The diagram above represents ball in an undulating surface. Which of the following options represent a stable equilibrium? Stable equilibrium. 73 is option C. I, this one, IV and IX. Option C. Okay. Skip. The diagram above shows 75. The diagram above shows the position of a cone. The position which can be described as a neutral equilibrium. Don't forget Z, option C. 75. Z only is a neutral equilibrium. We talked about that one. I even gave a short note for you to write. One of the conditions necessary for an object to be in equilibrium when acted upon by a number of parallel forces is that the vector sum of the forces is positive. The vector sum of the forces is 0. The vector sum of forces is supposed to be 0 because the clockwise force is supposed to equal and counterbalance the anti-clockwise force. So 77 is option B. 78. What happens when three coplanar non-parallel forces are in equilibrium? What will happen is that their lines of action will meet at a point. Option D. So 79 has to do with calculation. 80 has to do with calculation. Okay. 81, a bit of calculation. The question stops at 85. Yeah, all of them have to do with calculation. And so we've come to the end of chapter 6. That's based on equilibrium of forces. I would really like to start the calculations from this chapter. This is because 90.5%, in fact 95% of students would always complain about this chapter. They will say, most times the secondary school teachers will just skip it, or they will not even teach it at all. So I'll start from here and I'll solve the questions. Alright, if you've gotten to this point, well done. If this is your first time of watching, welcome back. If this is your first time of watching, welcome. Please do remember to subscribe to the channel and also leave a like. And if you're returning, you could also leave a like. That would help YouTube. That would help us for this video to get to more students who would also like to learn as yourself. One other thing I would like to introduce you to, we're running a daily smart class. If you'd like to be part of the class, I'm going to leave the link to the WhatsApp group in the description box. Thanks for watching. If you're able to jot down anything, snap the item and send to us on the WhatsApp group. I'll see you in the next video. Thank you.